this experiment, we're going to see what can happen when you put two substances together. Sometimes that when they come in contact, they form a new substance, and sometimes they just mix. If they form a new substance, then they've undergone a chemical reaction. That's the same thing as saying they've undergone a chemical change. So in our example, we're going to use hydrochloric acid. This is a strong acid. It's very harsh. It's corrosive. It will burn you. This is a solution. It's in water, so it looks like water, but this solution will burn your skin if you get it on your skin, so you'll wear gloves for it. And then we'll use, this is sodium hydroxide. This is a strong base. It also is very harsh. This won't sting or burn you that way, but it will make your skin rough. It's pretty harsh. If you had it on your skin very long, it would cause real problems. Otherwise, if it's in contact with your skin for a little while, it'll just make it real rough. If you wash it off, it would be like putting your hands in Clorox or something. So both of these are very harsh chemicals. Then when you put them together, you get a new substance, sodium chloride. Initially this is dissolved in water. We will do something to evaporate off the water, but initially it's aqueous. Sodium chloride is table salt. And our other product is water. Okay, so notice that the new substances that are formed are harmless. In other words, they are very different chemically than what we started with. And this is what happens in a chemical reaction. Often your products, because they are new substances, they can have very different properties than what you started with. Also, if I have some salt water, which is what I end up with here, I don't know of a way that I can take salt water and convert it back into a strong acid and a strong base. That's true with a lot of chemical reactions, not all of them, but often it's very hard to go from the product back to the reactant again. And if I did, it would require a chemical change to get there, not just a physical one. The other possibility is that when you mix two substances together, you bring them together, they just mix. They undergo a physical change. They each keep their own identities, and they are just physically mixed together. So making a mixture is just a physical change. Let's look at our mixture. We're going to start with just the salt and sand. You're going to add water, stir, decant / filter, and then you will have wet sand and salt water. So we've extracted the salt out of the sand salt mixture. Then you can just heat both of these to remove the water, and you'll get your sand back and you'll get your salt back. So it's pretty easy, just using physical methods to get back our original components that we put together. They retain their identity when we mix them together. Let's look at a calculation, because what we're going to do is we're going to look at how we made our mixture and then see how much of it we get back. See how much of our sand we get back and how much of our salt we get back. So this is an example calculation. Let's just say we started with 5 grams of salt. Your numbers will be different. and 2.50 grams of sand. That gives us a total mixture 7.50. That's how we started, and then we did our procedure and we ended up with a beaker of sand and a beaker of salt, and we're going to weigh those and see how much we get. So let's just say that we recover these amounts, and let's go ahead and add those together to see how much we recovered overall, or the total recovery. Okay, let's do some calculations. What percent of the salt did we recover? Well, how much did we recover? We recovered 4.75, oops, flipped that, didn't I? 4.75 grams. This is the recovered, and divided by what we started with, times 100. And we're going to follow our sig fig rules. Now our calculator will just say 95 when you divide this times 100. But we need 3 significant figures because these numbers each have 3 sig figs. So I'm going to rewrite that with 3 sig figs by adding a 0. Let's do a similar calculation for sand. Maybe you noticed we have something funny about the sand. Our percent recovery comes out over 100. We'll talk about that in a minute. Let's look at the recovery overall. So the recovery overall, I want to look at the total recovered overall divided by the total we started with. Okay, very good. Let's talk about, let's zoom out a little bit and talk about some of these numbers. Notice that our sand recovery is over 100%. What does that tell you? It tells you there's a contaminant in there. There's something else besides the sand. We didn't magically make sand as we did this experiment. So what else may be in there besides the sand? Well, there could be water. Maybe you didn't evaporate it long enough. Hopefully you'll go back. If your recoveries come out too high, you'll go back and make sure that the sand was totally dry. I would expect you to do that. If this number comes out over 100, I would expect you to go back and heat those beakers some more, both your sand and your salt beakers some more, to get rid of the extra water. That would be because there's extra water. But if the salt comes out, I'm sorry, the sand, it's not because of water. It doesn't have to be because of water. If you think about how we do this separation, we added water to our sand and salt, which made salt water, and then we decanted that off. Well, there's some salt water left on the sand, and while we can evaporate off all of the water, there's going to be some salt left on your sand. That will do two things to your numbers. That will make your percent recovery of sand over 100 typically, and often your percent recovery of salt is lower than this. This one's pretty high. It can be quite a bit lower, and so you may have as much as 5 or 10% of your salt actually end up with your sand.